Hello, dear student. I am Aditya Gupta, and a very warm welcome to this lecture on the topic of triangles. Now, in this chapter, we'll basically be mainly be looking at the congruence of triangles and inequalities related to triangles, right? Now, in a CBSE board exams, the weightage of this chapter is around 5 to 7 marks, right? And of course, this is one of those fundamental topics that was discovered long ago as far as congruence is concerned. And we must know, like in the study of triangles, it is the very first topic that we come across. Then we will also study some other topics later in our higher classes like similarity, trigonometry, etc. But first of all, we will study the topic of congruence, right? Now, and of course, some inequalities as well. Some basic properties of triangles we have already studied in lower classes and in the previous chapters, like angle sum property, right? What is the formula of area of a triangle, half into base into height? So some aspects of geometry related to triangles we already know. Now let us see what we have here in this particular chapter. So here we have a few topics that we need to cover. So for example, congruence introduction, right? Congruence of plane figures and triangles, and then criteria for congruence of triangles. These criteria we'll be mainly looking in the next lecture, but a basic idea we will also be having in this lecture, okay? So let's see what we first mean by congruence of any random figure, right? Congruence of any plane figure and any triangle. If two objects are of exactly the same shape and size, they are said to be congruent. Very important. They should be exactly of the same shape as well as same size, right? Then they will be said to be congruent. The relation between two congruent objects being congruent is called congruence, right? So that's what we call congruence, that they are congruent, as simple as that. The method of superposition examines the congruence of plane figures, line segments, and angles. Two plane figures are congruent if each, when superimposed on the other, covers it exactly. Very important. This will also be looking at, in the next slide. But before that, let us understand what we are saying. That if one figure can be superimposed exactly over the other figure, it means that they are congruent. This not only applies to plane figures, but also to line segments, angles, as well as, points. So basically, any 2 points are obviously congruent. The reason is one point can easily be superimposed over the other point. But line when will we say that two line segments are congruent? This is very important to understand that any two line segments, if there are AB, let's say, and there is also another line segment, yeah, here we have AB and CD, right? Then they will be congruent if and only if their lengths are equal. Why can we say like this? Because let's see here. Look, what we are saying is that whenever we have two lines, they will be congruent if and only if their lengths are equal. The reason is that if their lengths are equal, then I can pick CD and put it over AB, right? So for example, CD I can bring here, CD I can pick and bring here, and then I can rotate this D, this point D, to bring it and coincide with B, with the point B, so that they will be coinciding. And of course, since their length is same, they will coincide exactly one over the other. Had their lengths not been same, then clearly there would have been some space left on the longer line, and hence they wouldn't have been congruent. So two line segments are congruent if and only if their lengths are equal. Very important to understand. Similarly, two angles will be congruent if and only if their angle measurement is equal. The reason is, let us say there is an angle maybe 35 degree, let's say, and there is another angle which we want it to be congruent to this one. Then look, if I bring if I pick this angle, this ray, let's say OA ray, if I pick this ray and let it coincide with, let's say, P point and Q point with this ray, if I want it to coincide, right? So so O will come here, maybe A will come here. So these two lines, these two rays have coincided exactly. Then obviously this other arm of this angle, if it is not exact, if we want it to exactly coincide, then obviously this angle also must be 35-degree only, right? If it is even a little bit less or more, then it will not coincide exactly, and hence two angles will be congruent if and only if their measurements are equal, right? So, as far as congruence of line segments, points, and angles is concerned, it is very easy. Line segment, 2 points will always be congruent. Two line segments will be congruent as long as their lengths are equal. Two angles will be congruent if and only if their measurement of the angle is equal. That's it. Two plane figures are congruent if each, when superimposed on the other, covers it exactly. So obviously that is true for anything, not just for plane figures, right? Congruence is denoted by the symbol this. So it is basically a curvy, a curve and then wavy curve and then equal to sign. This is a symbol of congruence whenever we want to state that this particular object is congruent to the other object, we put this particular sign. If two line segments have the same or equal length, they are congruent. As I have already discussed that two line segments will be congruent if and only if their lengths are equal. If two line segments are congruent, then they have the same length. So if and only if already covered both of them. If and only if means A implies B as well as B implies A. So here these statements have been written in two separate parts. If two lines have same or equal length, they are congruent. If two lines segments are congruent, they have the same length. It is the same as saying two lines will be congruent if and only if they have the same length. So that this we have already discussed. About angles also we have discussed. They will be congruent when they are exactly equal in their measure, right? So now let us see congruent figures. Yes, now comes an important thing. Two circles of equal radii are congruent. In fact, if two circles are congruent, they will have equal radius. So we can say two circles will be congruent if and only if their radii are equal. The reason is that if there is, let us say, a circle here, right? And there is another circle here with some center and some radius. I don't know how much. Okay. But what does it mean for them to be congruent? That if I superimpose them, so let's say I bring it here, I bring it center exactly on the same center as this circle center. So if I make their centers coincide, then obviously if they have the same exact same radius, then they will clearly coincide or superimpose each other. But if this circle has a smaller radius, then it will look like this it will appear as a concentric circle with smaller radius. If it has a larger circle, it will still appear as a concentric circle but with larger radius, which is clearly implying that they are not congruent since they have not superimposed each other exactly. That's the whole point. That's how we have come to the conclusion that two circles will be congruent when their, if and only if their radii are equal. Okay. Two squares will be congruent if and only if both sides, if and only if they have equal sides. So if they have equal sides, they will be congruent. If they are congruent, they will have equal sides. This is also pretty obvious. The reason is that, of course, if we have a square and if we have another square, then let us say I want to superimpose this particular angle here. So obviously if their side lengths are not equal, then either it will go this particular square will become like this or it will become smaller. If we want exact superimposition, then side lengths obviously must be equal, because On superimposing, they have the same side lengths, right? It is pretty obvious here. Now, let us talk about congruent figures in general once again. As I said, if two angles have the same measure, they are congruent. Also, if two angles are congruent, their measures are the same. So, of course, as I said, that two angles are congruent if and only if they have the same measurement of the angle. If two angles are congruent, then the lengths of their arms do not matter. Of course, they do not matter because you make this angle 30 degree, you make this angle 30 degree, but the angle itself is congruent, right? Angle itself is congruent. How it doesn't matter how long you extend the arms, correct? For instance, here we have shown smaller arms, bigger arms, but clearly the angles will superimpose each other if kept exactly over one another, right? Now, when two triangles are congruent, if all the sides and all the angles of one triangle are equal to the corresponding sides and the corresponding angles of other triangle, then they will be congruent. Okay. So what we are saying is, if two triangles are congruent, if and only if all the sides and angles of one triangle are equal to the corresponding sides and angles of the other triangle. We'll look at this in further detail. But right now, this point we should be able to understand. For instance, we are shown here that two triangles, ABC and PQR, then clearly what should happen here is that AB length should be equal to PQ length. Then BC length should be equal to QR length. Then AC should be equal to PR. Then angle A should be equal to angle P. Similarly, angle B, angle Q, angle C, angle R should be equal to each other. So that's all we are saying. By the way, what do we mean by these symbols? So if I'm making for two angles, if I make this kind of a symbol, it means these two angles are equal. Okay. So here I have drawn two lines here, two lines here. It means these two angles are equal. Only one line here, only one line here. This means these two angles are equal, right? Similarly, three lines here means these two angles are equal amongst each other. Okay. As far as side lengths are concerned, how do we draw? If I draw one line here, it means these two side lengths are equal. Two lines here, it means these two side lengths are equal. Three here means these AC and PR are equal. Okay. Just a representation, nothing much. Okay. One important thing we will also note later is in how many ways can we name this angle. Okay. So we'll come to that, but let us first see what we mean by a triangle. It is a closed figure formed by three intersecting lines is called a triangle. Okay. It has got three sides, three angles, three vertices. Okay. It is very clear from the diagram itself. It has obviously got three sides, three angles, 1, 2, and 3, and three vertices. Okay. This triangle can be denoted as triangle ABC. We can also name it as triangle BAC, triangle CAB, triangle CBA. So there are total 6 ways of naming this triangle. Triangle ABC is fine, triangle ACB is fine, triangle BAC is fine, triangle BCA is fine, triangle CAB, triangle CBA. These are all valid ways of naming this particular triangle. ABBCCA are obviously the three sides. That's the way we will name these sides. This side will be called side AB or BA, BC or CB, and this side will be called AC or CA. Angle A, angle B, angle C are three angles, okay, and ABC are three vertices, which is obviously correct. What other way can we name this particular angle A? Angle A means this angle, obviously. Another way of naming this angle can be angle BAC. Angle BAC. So you go from B to A, then to C. Then the angle that you are getting can be named as BAC. Okay. We can obviously also name it as angle CAB, but that's it. These are the only three ways of naming this angle. There is no other way to name this particular angle. Okay. Angle BAC, angle CAB, angle A, that's it. No other ways of naming this angle. What about angle B? How can we name angle B? One of the ways is angle B itself. Another way can be angle ABC, because from A to B we go, then from B to C we go. Then obviously the angle made is this angle only, correct? We can also name it angle CBA, because you can also go from C to B, then from B to A, then also the angle created is the same angle. So these are the only three ways of naming this particular angle. Similarly, you try on your own. What other two ways can we name this angle C? Okay, try it on your own. One of them I'll tell you, don't worry. Angle C we can, let's say, name like angle BCA. One of them you try on your own, correct? So that's pretty much how we can name the angles in a triangle. And sometimes if we talk about a general angle, then whenever we write angle ABC, or let's say these are PQR to avoid confusion, let's say these are PQR points, then if we want to name this angle, we will name it angle PQR. But if we want to name this angle, then also we will name it PQR only, obviously, because for generating angle beta, we are going from P to Q, then Q to R, then this angle is also correct, right? But we will write to avoid confusion as to which angle we are talking about, we will name it angle PQR reflex. Why is it reflex? We have already seen in the chapter lines and angles that an angle which is more than 180 degree but less than 360 degree, we have to write reflex in front of that. Okay, so until and unless we have written down the word reflex, it is automatically understood that we are talking about the non-reflex angle, right? So here when I have written angle BAC, it is automatically understood that we are talking about this angle and not this angle. Okay, so pretty obvious things, but I wanted to make it clear so that there is no doubt. Now, congruence in general, if we are talking about, congruence in general means not just for triangles, but for any figures that might be of our interest. So, how do we define congruence in general? Formally, any two objects are called congruent if and only if one object can be transformed into the other by an isometry. What do we mean by isometry? Isometry means a combination of rigid motions. And what are those rigid motions? Namely, a translation, a rotation, and a reflection. So that's it. What we are now, let's understand what we mean by translation. So let's say we have some object here, we have another object here, then obviously I can so translation means, look, if this is a pen, let's say, and we want to translate it in space, translation means it can move anywhere, it can move anywhere, okay, up, down, south, west, okay, in any direction at all. Okay, basically translation means it remains as it is and moves parallel to itself. Okay, it can move anywhere at all. Okay, in fact, if we talk about any other object, let us say this is kind of a rectangle, so we can move it anywhere. So this also constitutes translation, that it is not rotating, turning, twisting, it is not getting reflected, it is not getting bigger in size, nothing. The only thing that's happening in translation is that it is moving parallel to itself, forward, here, anywhere it can move. Okay, but it cannot rotate, it cannot reflect itself. Okay, it cannot twist itself. Okay, translation just means that it can move anywhere. Let's say my hand we are talking about. What about my hand? So my hand can move like this, my hand can move like this, like this, anywhere at all. This constitutes translation. Fine. So here, obviously, in our example, I can easily translate it from here to here, and it will easily coincide over the other. It will superimpose the other object just by a mere translation. Yes. What about a rotation? We have a pen. If I want to rotate it, I can rotate it like this. Okay, it is rotating. I can rotate it like this also, right? So that's what we mean by rotation. If we have a mobile phone, smartphone, then this also can be rotated like this. Okay, it's being rotated. right? My hand can also rotate from this direction to this direction, from here to here, okay? So that's what we mean by rotation, that any particular object is being rotated about any axis. Absolutely any axis we can rotate it about. So what I'm saying is, it is not necessary that it should be the middle axis only. No, we can rotate it about any axis. For example, if I talk about this pen, I can make this point as the axis and rotate it about this also. Rotate it about this also. It is not necessary that I have to hold it from the middle only and then only rotate. No, it is absolutely allowed to choose any axis about which we want to rotate that object. Okay. For instance, if I talk about my hand, let's say I choose this axis, this, my finger is representing the axis, then about this also it can rotate. So rotation is allowed in any manner that we wish. Now, what about, so let me draw an example. If we have a, let us say a triangle, or let us use a rectangle, it would be easier to understand. So here we have, let us say, a kind of a rectangle. And of course, if I rotate it, then maybe it will look like this. I have given it a rotation of around 30-degree clockwise. Okay, the figure is not very exact, but you get the idea, right? That it has been rotated by some angle theta and we get this figure. Okay, so this was the rectangle, you rotated it like this, you got the second figure, right? So that's pretty much what we mean by rotation. What about reflection now? Understand this carefully. Reflection means that, look, right now we are only talking about congruence in 2D. Okay, forget about 3D. Only in 2D we are concerned about congruence. So in 2D, what I'm saying is that we have any figure. Let's say this figure we are talking about. Then reflection means that you can place a mirror absolutely anywhere you want, and the resulting reflection of the figure in that mirror or the image in that mirror is referred to as the reflection. So, for example, if I place a mirror here, let us say, the image will kind of look like this. It is a little bit difficult to draw, but I'll try to draw as nicely as possible. Okay, something maybe like yeah, something maybe like this. Okay, I think a little more like this. Yeah, so this will be the reflection or the image about this particular mirror that we are talking about. So this is the reflection. We can also place a mirror like this, like this, cutting it also we can put a mirror. So then this portion will get reflected. How will it be reflected? Yeah, something like this. Okay, I think I have drawn it very thin. It should be thick, right? And this portion will be reflected like this. Okay, this portion has been reflected like this. Okay, so this resulting figure is the reflection then. Okay, so reflection is also allowed. So as long as one of the figures can be superimposed over the other, either by translating or by rotation or by reflection or by a combination thereof, then it will be called that, yeah, they are, if the both of them are superimposing over each other by either of these motions, then they will be said to be congruent. Very formal definition we have seen here, but what does it mean basically, from an understanding perspective? It means that either object can be repositioned and reflected but not resized. Very important to understand, we cannot resize. For instance, many times we have an image using a mobile phone, a smartphone, or a computer. We often zoom it to make it bigger so that we can see better. Sometimes we often zoom out. Sometimes we want to zoom in also. So that's what we mean by resizing. But resizing is not allowed here. Okay, resizing is not allowed. If you resize, then they will no longer be congruent, right? That's what we are saying, that if one of the figures or one of the objects can be repositioned or reflected but not resized so as to coincide precisely with the other object, then they will be called congruent. In fact, if I want to find the reflection of, let us say, this object, then either I can place a mirror and find the image, but there is another way actually to find the reflection. I can simply twist it. I can simply invert it exactly like this. So if I want the image of, for instance, this object right now, how can I get the image? This is the image. Okay, this is the image. If I just invert it upside down, then this will be the image about this mirror. Okay, so what we are saying is that two distinct plane figures on a sheet of paper are congruent if we can cut them out and then match them up completely. Turning the paper over is permitted. And what does turning the paper over represent? It represents inverting, which is equivalent to reflection about a mirror. So turning over the paper actually is representing reflection only, and hence this definition, this understanding viewpoint is equivalent to the formal definition as well. So if there are two figures drawn on a sheet of paper, and if we can cut one of them and then somehow we can match it up completely or superimpose exactly over the second figure, then they are congruent. We can do anything with that paper figure. We can translate it. Obviously we will have to translate it. We can rotate it. We can also invert, turn the paper, and then try to, so anyhow, if we are able to superimpose, they will be congruent figures. Now let us see an animation for these two objects. Okay, these two objects. What about these two objects? They are congruent. Why? Because look, one of them is exactly able to superimpose over the other. And what has taken place? Which of the rigid motions took place here? Translation. So this was an example of translation alone, where I just did a translation of one object to superimpose over the other. So yeah, they are congruent. But not just translation, rotation and reflection are also allowed. But in our example, only translation took place. Now, criteria for congruence of triangles. First of all, we have already seen what is a triangle made of three line segments. Two triangles are congruent if their corresponding sides are equal in length and corresponding angles are equal in measure. Of course, if all the six measurements are equal, then obviously both the triangles will be congruent. So if all the sides of one triangle are equal to the corresponding sides, very important word, corresponding sides, of the other triangle, and also all the angles of one triangle are also equal to the corresponding angles of the other triangle, then they will be congruent. Okay, now congruent, so all the six measurements, if they're equal, then obviously they will be congruent. Congruent triangles are triangles having corresponding sides and angles to be equal. Correspondence, a congruence is denoted by this symbol. They have the same area and same perimeter, which is obviously not a surprise at all. Obviously, everything about them will be the same. Perimeter will be same, area will be same, median lengths will be same. You know, any property at all will be exactly the same because they are essentially the same triangle, right? All because they are congruent means they can be superimposed over each other. So everything about them is going to be the same. Not just the perimeter, not just the area, but any other property that we can think of. Now, how, for example, now correspondence is very important. Many students make a mistake in understanding correspondence, and without understanding this concept, we cannot proceed with this chapter. So let us have a look at this example. Here, obviously, ABC triangle and DEF are congruent because side AB and DE are equal. Okay, BC and EF are congruent. So basically we can see corresponding parts must be equal. We will have a look at this in greater detail in the next few slides. But the point I'm trying to say is that you can't write triangle ABC is congruent. If you write here triangle ABC congruent to triangle EDF, then that would be incorrect. You can only write ABC congruent to DEF only. You can't change to EDF because then corresponding parts will not be equal. So that's, this naming also is very important here. Okay, if you want to name the first triangle as BAC, that's fine. But then the second triangle will also need to be named as EDF. This is correct. Okay. So correspondence is very important. It's not that if two triangles are congruent, we can name them in any way. No, we need to make sure the correspondence is maintained. What it means, we'll see in the next few slides in more detail. Here, how will you write, for example? Clearly, triangle ABC should be congruent to what triangle? How should I name it? I think it should be RPQ. The reason is AB equal to RP. Both of them are 3.5 centimeter. BC is equal to PQ. So let's see, BC equal to PQ is also true. And of course, CA is equal to QP. CA is equal to QP, both are 5 centimeters. So indeed, I have written the correct congruence. Okay, I could not have written PQR here. I could not have written QRP, QPR. Only RPQ can come here if ABC has come here. So correspondence is very, very important to take care of. Okay, congruence in a triangle. Now, as I was saying, let us understand that if we consider triangles, two triangles ABC and XYZ, then such that their corresponding angles are equal and corresponding sides are equal. So what we mean is, first understand that if there is a triangle whose name I have called ABC and another triangle whose name I have called XYZ, then corresponding points will be automatically defined. Point A corresponds to point X, point B corresponds to point Y, point C corresponds to point Z. Okay. So if I want to make side AC here, then since I have chosen the first and third letter A and C, here also I will have to choose first and third letter only, so that we get XZ, and then we can call this as corresponding sides of these two triangles. Forget about congruence right now. Just focus on whenever we have two triangles, whenever we have named them in a certain way, then how do we consider how do we consider their corresponding parts? That's what we need to first understand. Then we will talk about congruence as well. So if I want to ask you what will be angle B corresponding to, so of course B is the second letter, then here also second letter, so angle B and angle Y are corresponding parts. For congruence, they all will be equal. That is another thing. But first we should learn how to name corresponding parts, right? If I want to name this angle as not angle A, but I want to name it angle BAC, let's say, then what will be the corresponding angle here? So look, BAC, second letter, first letter, third. Then here also YXZ needs to come. Okay, this will be the corresponding angle. So this is such an important thing that as soon as we have named the triangles, their corresponding parts, corresponding points, everything is automatically defined. Okay, so naming the triangles is very important to name it correctly. So if I have named, now clearly here we can see that in these two triangles, since they are congruent, corresponding parts are equal. So for example, AC length is equal to XZ, as you can see, and AB length is equal to XY. Okay, and from here also we are getting AB equal to XY only, right? BC correspondingly, how much we are getting? Look, second letter, third letter, second letter, third letter, so BC equal to YZ. So that from there also we are getting correct only. Angle, now BC equal to YZ, right? Now what about angle A? Angle A and angle X are corresponding parts which will be equal in case of congruent triangles. Similarly, angle B and angle Y are equal, angle C and angle Z are equal. So that's pretty much what we were trying to point out. And here we have a very good question. These two triangles are congruent under the correspondence. Such an important thing. Under this correspondence, they are equal. Right now, they have named the triangles in any manner that they wanted, ABC and PQR. But for congruence, the naming needs to be exactly matching. Okay, so in these two given figures, you have named here, you have named this triangle ABC, PQR, doesn't matter. But when you are talking about congruence, if you have named triangle ABC in this way, then RQP comes here, because here look, this has been inverted in this manner. So A point corresponds to R point, B point has gone actually here, and it hence corresponds to point Q, and C corresponds to P, and hence ABC will, so you can also say like A corresponds to point R. So, B corresponds to point Q and C corresponds to the point R. So if I write ABC, then they will correspond to RQ. Okay, here I have done a mistake. It will be P, right? So RQP. What parts of the triangle ABC are there that correspond to angle P? So obviously angle P is the third letter here. So angle C. Angle Q will correspond to angle B only. And RP will correspond to AC. First and third letter, right? Or we can, so that's what we are saying, that RP will correspond to AC and these angles as we have written here. So here we have a solution also, that point A corresponds to R, B corresponds to C, B corresponds to Q, C corresponds to P. So PQ and CB, QB and RP is AC. So I think we have also written the same. Q corresponds to B, and okay, here we have P, Q. So although there is a error in this question, so here we had angle P, but even if we had PQ, obviously it will correspond to CB as we have here. Okay, so this is important to understand. Now let us talk about some good practice questions here. Which congruence statement is true for the following triangles? So let us start with the D option. Let us assume this is true. Let us say they are actually congruent. If that is the case, then what can I say? I can say that KL length must be equal to MN length. Am I right? MN length must be equal now. But clearly this is not true because KL and MN are not equal. KL is equal to NP, not MN. So this is obviously false. What about KJL? KJL and NPM. So KJL and NPM is also false because let's say I want to take corresponding side KJ here, then it must be equal to NP if they are congruent. But KJ and NP are obviously not equal. This is the hypotenuse, this is this side, and here it is given now that this is single line, this is single line. It means JL and NM are equal. They are not equal. So KJ and NP are not equal. So this is also crossed. LJK and PMN. So let us talk about LJ. If this is true, then LJ must be equal to PM, but LJ and PM are not equal because this is a single line, this is a double line. So clearly this is not true. So this will be the correct option because look, here all the things are satisfied. JK equal to MP, is it true? JK equal to MP, yes. Both of them have a two lines. Similarly, KL, if I want to take, what will we get? KL will be equal to PN. Is this true? So let's see, KL and PN are indeed equal. So this is also true. Similarly, JL will be equal to MN. Is this true? JL equal to MN. Yes, this is also true. We can also talk about angles. So angle JKL should be equal to angle MPN. Is this true? JKL is this angle, MPN angle is this? Yes, they are equal. Similarly, the remaining angles also you can write. Okay, in fact, rather than writing so much, we can directly write angle L will be equal to angle N. Angle J should be equal to angle M, which is true or not? Angle J equal to angle M and angle L equal to angle N. So since all these 6 properties are holding true, clearly this is correct. Now let us say they did not give us option and asked us to write on our own. Then what could we have done? The first triangle's name we could have written in any way at all that we wish. Let's say I want to write LKJ. It's our choice. But the second triangle's name I should write correctly. Okay. Correspondingly, I should write. So clearly, this L has gone here, right? So L is corresponding to N, then J corresponds to M, and K corresponds to P. Easily we can observe. Okay, let me draw better. Let me just make it a little bit cleaner to understand. So clearly, this triangle has just been, what has been, how has it been transformed here? First of all, we can say that it has been reflected. So how will it be reflected? So if I reflect it about here, we get something like this. Am I right? So we will get K, J and L, and now I can simply rotate it. So if I rotate it in this direction, we will get that this KJ length, which had a double on its, okay, here we have one and triple lines here. If I rotate it like this, then if I rotate it in this direction by 90-degree angle, I will get something like this, that L, J and K, it will look like this. And of course, it will look something like this. So obviously these two are the exact same triangles. So indeed they can be superimposed. So that's what we are saying, that L point corresponds to N, J corresponds to M, P corresponds to K. So what should come here? N, then M will come here, K corresponds to P. So P will come here. So this is the correct congruence that we have written. If we want to write it JKL, then JKL will be congruent to MPN, which is also written correctly here. That's why this will be our correct answer. We will learn a shorter trick way also of doing this. So, but first let us solve this question. In these two triangles, angle P equal to angle K, PQ is equal to KL, angle Q congruent to angle L. Two angles are congruent if and only if they are equal, right? So angle Q equal to angle L also we can say which side is congruent to RQ. So look, these are named triangles here, but interestingly, angle P equal to angle K, angle P side PQ is equal to side KL. So correctly they have taken, and angle Q equal to angle L. Okay. So clearly they are already named correctly because all corresponding parts are holding correctly. So RQ length would be equal to ML. So ML will be the correct answer. So I hope this is clear to you. Let us have a look at the answers. Option A and option B, which is correct. Now let us also have a look at the trick way. Let us see if we have a triangle ABC, and let us say this is this looks something like this. Okay, and let us say there is another triangle PQR, okay, something like this, and let us say this is how it looks like. Okay, so now what can we say? So we can name this triangle in any way that we want. First triangle we can name any way we want. So let us say we name it as triangle BCA. It's my choice. I will name it like this, no problem. But now what triangle will come here? How do we know very quickly? Because if we write down all the 6 figures, it will become so difficult. So what we are saying is that whatever triangle comes here, we know that angle C, or we can say angle BCA, okay, must be equal to, or okay, let me write it like this only. Earlier what I was writing is an easier approach. We can say that angle C will be equal to how much? If we want angle C, then whatever letter comes in the middle, then obviously those corresponding angles must be equal. So angle C equal to angle what? What will come here? So clearly this angle C is equal to angle R. So R will come here. Then only corresponding parts will be equal. Angle C equal to angle R, which is true. Similarly, angle B must be equal to angle P. So P should come here. Similarly, angle A must be equal to Q. So Q must come here. So this is such a good trick. Just if we observe the angles alone, then we were able to write this. Now, all of them will be true now. if you take BC length, it should be equal to PR. Is it true? BC equal to PR. Look, automatically it is holding true. CA length should be equal to RQ length. RQ, okay. Is it true? CA, okay, CA length and RQ, they are equal. Similarly, BA length must be equal to PQ. BA and PQ are indeed equal. So automatically all the things are holding true as long as we have made sure just by a few parts, just we have written by a trick, okay, just using this trick, if we write the names of triangles, they are correctly in the corresponding congruent order. Okay, naming has already been taken care of using this trick. Just a few more points I would like to tell, then this lecture we will end. So every triangle ABC is congruent to itself. Of course, if any triangle is congruent, if there is any triangle, then it will be congruent to itself. This is our first point. Second point we should know is that triangle AB, if triangle ABC is congruent to triangle DEF and triangle DEF is congruent to triangle PQR, then triangle ABC will be also congruent to triangle PQR. This is also very obvious, right? So this is something that we should be aware of. So let's say if I give you a question, very easy question. Let's say triangle BCA is congruent to triangle DEF, and let us say triangle FED is congruent to, let's say, triangle PQR, then you have to tell me that triangle ABC will be congruent to what in terms of PQR. Okay, so basically we have to write the congruence order of triangle ABC and triangle PQR. How should we do that? So look, this is a very easy question only. Here we have DEF, right? So here also I would want DEF. So if I send D here and F here, first and third letters I have interchanged, then here also first and third letters will get interchanged, right? Because point F corresponds to P. Here also F corresponds to P. E corresponds to Q. Here also that is maintained. And D corresponds to R. That all here also it is maintained. So this I can write, correct? From this we can conclude this. So now DEF is congruent to this also. DEF is congruent to this also. So using this second property, triangle BCA will be congruent to triangle RQP. So that's it. This is the congruence order in which we should write these two triangles. Okay. So that's easily how we can solve this particular question. So I think that's pretty much it about this lecture. I hope you enjoyed watching the lecture and learned something new. Stay safe and enjoy your studies. Once again, thanks a lot for watching. Bye-bye.